Hello everyone. So we will wait for 5 to 10 minutes and then we will start since I can see that not many students have joined. So we'll wait for 5 minutes and
Yes,
then
ma'am.
we'll start.
Yes.
Okay. Okay. Hi everyone. So let's start the session. Mm, yeah. So today we will be studying assignment 1, assignment 3, week 3. Previous year we will be solving previous year's assignment 3 and so sorry you guys had to wait for 15 minutes, sorry for that. So chalo, let's start then. Okay. Okay, so week 3 assignment 3 previous year question we are going to solve. So the first question here is the transfer function of a plant is ts is equals to 10 upon s plus 5 s square plus s plus 1. The second order approximation of ts using dominant pole concept is. So here what is asked is transfer function is given to us. Okay, transfer function is given to us. Now it's asked that second order approximation of transfer function using dominant pole concept. You get it? What is asked here? Now you try to solve the question. Okay. Going to give you 3 minutes. You solve this question. These are the options given to us. Try to solve. Then we will discuss the solution. Am I audible?
Yes, ma'am.
Okay, okay. Try to solve.
Yes, ma'am.
What about others? Chalo, I guess. Yeah, so no one is solving, I guess. Okay, so let's try to solve this one. So we know the transfer function, right? We know that transfer function is equals to 10 upon s plus 5 into s square plus s plus 1. So poles here are at s is equals to minus 5, which is okay, so s is equals to minus 5, and another pole is at minus zero point 0.5 plus minus j 0.86. You got till here? Got till
Yes,
here?
ma'am. Yes,
Huh.
ma'am.
Any doubt?
No, ma'am. No, ma'am.
Okay. Now, so here what we can see is minus 5 and minus zero point 0.5. So minus zero point 0.5 is greater than minus 5 by 4 times, right? So this one is a dominant pole, right? If we talk about the this magnitude, then it's a lesser than 4 times. So this is the dominant pole for high frequency response. So for high frequency response, if we divide minus 5 the magnitude by 4, then we'll get some value which will be above zero point 0.5. So this one will be the dominant pole. So now for second order of approximation, what we have to do is we have to limit s is equals to tends to 0, we have to put on the transfer function. So from here we have to find a value k, right? So using this we got 10 by 5 is equals to 2. Now uh, we, so second order approximation will be k divided by the dominant pole. So here we got k, which is 2 divided by dominant pole, this. So this is how we get second order approximation. You have any doubt?
No,
Anyone?
ma'am.
Anyone else? Any doubt? Okay, let's go then. Let's move ahead and try to solve next question. So here option C looks like the correct one, right? So option C. Now let's go to second question. With the feedback path,
Ma'am,
hmm,
what is dominant pole, ma'am?
okay, so dominant pole for low frequency and high frequency response is something like this. See, so this is what a frequency response is, right? So that pole which dominates the characteristic of the transfer function. Okay, so that pole is known as dominant pole. So here, due to this pole, omega p1, due to this pole, the function which was going like this suddenly became constant, something like this, right? So this is dominant pole. Similarly, this is for low frequency response. This is for low frequency response. Similarly, there will be another dominant pole here, omega p2. Will say this will be dominant pole for for high frequency response. So here it was coming uniform, the transfer function was uniform, the frequency response was uniform, and suddenly uh, its characteristic changed due to this dominant pole. So this is what dominant pole means. So this is low frequency dominant pole and this is high frequency dominant pole. So generally what happens is, for low frequency dominant pole, the pole or zero, nearest pole or zero will be 4 times less. So this will be, let's say another, let's say there is omega p0, right? So which is nearest to omega p1. So omega p1 will be at least 4 times greater than omega p0, right? Similarly, omega p2 will be at least 1 by 4th of the nearest pole here, right? 1 by 4th times omega p3, let's say. Got it? Got
Okay,
it?
ma'am.
Hmm. The magnitude. We are talking about the magnitude. Okay. So now let's go to second question. So second question here is, with the feedback path added to a system with gain factor of alpha, what happens to the overall gain of the system assuming value for open loop gain alpha beta? One second, let me confirm. Okay, so you guys solve this question. So you can you read? Everyone can read.
Yes, ma'am.
Yeah. So solve this one. I'm stopping to share for some time. Give me 2 minutes.
Okay.
to display the question, ma'am, once.
Okay, sorry. I guess it's gone. 1 second.
Option D.
Okay, what about others? What others think?
Shower, ma'am. Same, ma'am.
Okay, chalo. Yes, so option D is the correct option. Why you think option D is the correct option? So first is transfer function. Okay, so and second one is gain bandwidth product, right? Okay, chalo. Let's see how to solve this question. Okay, so the transfer function is equals to DC gain, which is the K here, DC gain into 1 upon 1 plus S divided by omega 3 dB. This is the formula given for the transfer function, right? This is the formula given for a amplifier. So transfer function is DC gain into 1 upon 1 plus S divided by omega 3 dB. So here omega 3 dB is 2 pi into F. So F is the one which was given to us, which was 600 kilohertz. So this is given. So omega 3 dB is 1.22 pi into 10 to the power 6 radian per second. Any doubt here?
No, ma'am.
No. Okay. So, by similar, then we don't have anything. Put all the values in the transfer function formula, and you'll get this, right?
Yes, ma'am.
Ha. Okay. Now let's go to gain bandwidth product. So, gain bandwidth product will be, we have the DC gain, right? We have the DC gain. We also have the bandwidth. We will multiply. We will get 900 megahertz. So this is gain. Simple. What is the here? It's gain bandwidth product. So just multiply gain and bandwidth, we'll get this thing. Any doubt here?
No, ma'am.
No. ठीक है. ठीक है. So let's go ahead and solve question number 4. For a circuit shown in below figure, find V naught in terms of V1 and V2 if GM is 150 milliamperes per volt and R is equals to 7 kilo ohms. So R is 7 kilo ohms. GM here is 150 milliamperes per volt. We have to find out V0 in terms of V1 and V2. Okay, so try to solve this question. This is a kind of circuit which you can say which is typically used in summer or subtractor, right? So so similar structure is given, circuit is given to us here. So now solve this question. Okay, Done?
Yes, ma'am.
Okay. What about others? Done? What about others? नहीं? Okay. Let's try to solve this question. Okay. So here given is that GM is 150 milliamperes and R is equals to 7 kilo ohms. So GM into R is given as this, right? Now, right? What is happening here?
Yes,
GM,
ma'am. Over.
हाँ, yeah, बोलो.
Nothing.
Yeah, so GMV1 V1 is going like this and GMV2 is going like this, right? So if we apply KCL here, then what we get? Something like this. Current IO can be said as this is the current, right? Current IO can be said as GMV2 minus GMV1. Is that clear? Is clear?
Yes, ma'am.
Ha, okay. So yeah, so we got IO is equals to GMV2 minus GMV1, and this is plus minus, this is VO, right? The voltage potential drop here at the resistor R. So what we got, V0 is equals to I0 R. So we already know I0 value, we'll put it GMV2 minus GMV1 into R. We got V0 is equals to 1050 V2 by V1. Any doubt here? So here it is, this circuit is working something like a subtractor. So here a voltage is given, here another input voltage is given, and basically what it is doing is, it is subtracting voltage V2 with V1 with some gain, right? This is what is happening. So it's a subtractor circuit. Any doubt here? Chalo, if you have got this value, so answer option D is the correct option, right? Chalo, abhi let's go, and I want everyone to solve this question. It's just you have to put it in the uh, function, in the formula. That's what you have to do. Okay, so for a circuit shown in question number 4, find V0 if V1 is equals to V2 is equals to 1 volt. What will be the new value of V0 if V1 is equals to 0.99 and V2 is equals to 1.01? So first is V1 is equals to V2 अगर if V1 is equals to V2 है, what will be the value of V0? And if V1 is 0.99 volt and V2 is 1.01 volt, then what will be the voltage output? So try to solve this question.
Option A.
Okay. Let others also solve. Done? Everyone?
Yes, ma'am.
So what is the answer? Go ahead. नहीं नहीं बोला किसी को. One second. Anyone?
Option A, ma'am.
Huh? Option A. No, option A is not correct, but no problem. Option C is the correct one. So how option C is the C? So 1050 is already given, right? Gain GMR is already given to you. Only V2 minus V1 was you were supposed to do. So for in first option, when V2 and V1 will be equal, then 1050 into 0, that's 0 volts. Okay. Second will be if V1 is 0.99 and V2 is 1.01, so we got around 21 volts. So what? Okay, so what does this show? If V1 and V2 are equal, right? Then you can see around. So you don't see any output at the this thing, at the output, right? But when there is even see only how much difference is there? Only 0.02 difference is there. But still, since gain is very high, you are getting around 21 volts. So this says that this one is a good amplifier, a good subtractor, because it is very sensitive. Even for a 0.02 difference, it is catching up. It can sense point, even 0.02 value it can sense. Understood? This is what the meaning is here. Okay, so let's go.